So today we're going to be talking about direct variation. You'll be able to identify a direct variation situation, write an equation that is a direct variation, and graph it. So I've got a simple situation here where I've got a recipe for paella that calls for 1 cup of rice to make 5 servings. So I'm making my paella, and for every 5 people I've got coming over, I'm going to need a cup of rice. So I'm looking to write this in function notation, and I notice that for every x, f of x, I've got a relationship of 5x. So when I plug in my 1 for x, I get a y of 5. Notice that is the slope of my line, what we've been talking about all along. I've got a change in y of plus 5 every time, a change in x of plus 1, which gives me a slope of 5. My change in y over change in x. So my function f of x equals 5x works because when I put in my 1, I get out a 5 when I multiply by 5. Putting in a 2 gives me 10, which is exactly what I want. Well, this is a direct variation. Let's take a look at what that means. So for a direct variation, it's a special type of linear relationship, and it's written in the form y equals kx. Notice that k is just where I had my m or slope value before. K is a slope value. The difference is in direct variation, we're going to see it only applies in certain cases. So we read this as y varies directly as x, where k is a non-zero constant called the constant of variation. So this k is just simply known as the constant of variation. Exactly like my slope, but in a direct variation, it's called the constant of variation. Also, to note, a direct variation equation must pass through the origin. Let's think about why that makes sense. When I had my slope-intercept form, my y equals mx plus b, my b, of course, was my y-intercept. There is no y-intercept here. My y-intercept is at 0, plus 0. So given that this y equals kx is my direct variation, I cannot have a y-intercept other than 0, which means all of my equations will pass through the origin. We'll see that a little bit more in a minute. So I want to know if this example represents a direct variation, and if so, to identify it. So I'm going to figure that out by solving for y. Remember, I need to know that it fits in the form y equals kx. Well, to do that, I need to isolate my y. So I'm going to subtract 2x from both sides, which gives me 3y equals negative 2x. And then I'm going to divide by 3 both sides to isolate my y. So I get y equals negative 2/3 x. So my k is negative 2/3. My constant of variation is negative 2/3. My y varies directly with x. That constant of variation is negative 2/3. Let's look at another example. I've got this example, 4x plus y equals 8. Again, I'm going to need to solve for y to see if it fits in the form y equals kx. I'm going to subtract 4x from both sides. And I've got y equals negative 4x plus 8. Well, notice I've got this plus 8 part, which means I do not have a direct variation. I've got a y-intercept of plus 8. If it's not coming from the origin, or running through the origin, this is not a direct variation. So I want to know, now I've got a table of values, I want to know if I've got a direct variation. Again, I can look for a function rule for this. I've got a change in my y's of 6, and I've got a change in my x's of 2, so I've got a slope of 3. So starting with that, let's see if that worked. So y equals 3x. Every time I plug in my 2, I get out 6. I plug in my 4, I get out 12. So this is my function rule, f of x equals 3x. Therefore, I have a direct variation with a constant of variation of 3. Since k is a constant, the same for every point, we can find k when given any point by dividing the y-coordinate by the x-coordinate. The k is constant for every point, remember, because my slope is also the same no matter where I am on the line. So let's look at what I mean by dividing the y-coordinate by the x-coordinate. Well, if y varies directly as x, so I've got a direct variation, y is 6 when x is 2, what is my constant of variation? Well, I could plug this in. Y equals some constant of variation times 2, therefore my k, dividing by 2 both sides, my k equals 3. Okay, I can also have rewritten that equation y equals kx so that I was solving for k, dividing by x both sides. I would have k equals y over x. So notice it's the same thing. I can just plug in my constant of variation is my y value, 6, over my x value, 2. So k equals 3. Here I've just plugged it into the equation to find the constant of variation, or I can just take it as a ratio of y over x. Okay, so let's look at this scenario. Is this a direct variation? I could look at this relationship and determine the function rule. I've got a change in y of plus 2, change in y of plus 4, change in x of plus 2, a change of y of plus 4. So I've got a slope of 1, which would be y equals x, except that if I plug in 1 for my x, I don't get out a negative 2 unless I subtract 3. So I do not have a direct variation because I'm not starting from the origin. I'm starting with a y-intercept of negative 3. Let's look at it also from just writing it as a ratio. K equals y over x, and I could plug in these values to check to make sure that it worked. So I've got k in this first situation of negative 2 over 1, so that's a k of negative 2. In my second ordered pair, I've got a k of 0 over 3. My k is 0. Plugging in my ratio of y over x, I've got a value of 4 over 7, which would give me a k of 4/7. I do not have the same constant of variation between these three sets of points. Therefore, this is not a direct variation. So, value of y varies directly with x. I know that I have a direct variation, y equals kx. I've got a y equals 6 and an x equals 30. I want to find y when x equals 45. Well, of course, I'm going to have to solve for my constant of variation. Remember, that can be written k equals y over x, and I've got a y value and an x value. So my k equals a y of 6 over an x of 30, which means my k is 1/5 when it's simplified. Now I've got an x value of 45, so my y equals 1/5 of 45, so my y equals 9 when my x value is 45. Let's look at another one. I'm assuming you know what you're doing at this point, so go ahead and pause the video and solve, please. So I've got a value of y that varied directly with x, and y equals 15 when x equals 10. So I've got a constant of variation of 15 over 10. So my k equals 3/2. I want to know what y is when x equals 8. So my y value with a constant of variation of 3/2 and an x value of 8, my y will equal 24 over 2, or 12. So, of course, I'm going to throw in a real-world situation. I've got a group of people tubing down a river at an average speed of 2 miles per hour. I want a direct variation equation that gives the number of miles y that the people will float in x hours, and then I'm going to graph that. So, the first thing I notice is my constant of variation is going to be 2. I know that for every x I plug in, I multiply by the constant of variation 2, that'll give me my y value. So my k equals 2. And what I'm going to do is I'm going to look for a set of points. So I'm going to make my little t-chart, x over y. At 0, I've got a y value of 0. At 1, I'm going to have a y value of 2. At 2, I'm going to have 4. And then I'll be able to graph these points. So it is a real world situation. So notice I'm only in the first quadrant because my x representing hours, because my x representing hours means I can only have a positive number, and my y of miles is again going to be a positive number. And I'm going to graph my points. Notice, of course, that I'm starting at the origin. I have a direct variation, therefore it must cross through the origin. 0, 0. I've got at 1 hour, I'm looking at 2 miles, at 2 hours, 4 miles. So I'm in effect graphing my slope, which is my constant of variation, or 2. Remember to take your online quiz, and I will see you on Monday.